Hello everyone. It's nice to see a lot of new faces. I'm very happy to be here to talk to you about Spotify's Akamai integration into our own CDN automation. There will be some code snippets in Python, but primarily there will be some storytelling and quite a lot of flowcharts. My name is Amanda. I'm from Stockholm, Sweden. I have a background in computer science at Stockholm University. I work as a network engineer at Spotify since 3 years back. First, I work with Spotify's data centers, peering and some private CDN build out prior to 1 year ago when a bunch of people, including me, formed a team focused entirely on content delivery. I would like to mention that I am an intermediate Python programmer. I'm not really an Akamai expert, but this is also why it was so fun to take on this challenge that I'm going to talk to you about. Before we start off, I would just like to mention a few things about Spotify to check in with you and make sure that you know what Spotify is. Then I will proceed to give you an overview of Spotify's multi-CDN environment and deep dive a bit into our in-house automation for CDN. Before diving into the case study of implementing the Akamai APIs, I would like to give you a few reasons why you should consider automating your CDN deployments. Hopefully I can answer your questions during the summary. So without any further ado, let's begin. So Spotify is both a free and subscriber-based on-demand music service with music, video shows, and podcasts. It's widely available in 61 markets with an active user base of over 140 million. Spotify is available on multiple platforms, ranging from mobile phones, computers, gaming consoles, smart speakers, TVs, and other peripherals like Chromecast and Apple TV. Spotify has offices around the world, with its technical operations based in New York, US, Stockholm, Sweden, and Gothenburg, Sweden. And now for the deep dive into Spotify's situation with this multi-CDN environment and more on the why and how we built our in-house CDN automation. Spotify has 3 different public CDN providers. And alongside those 3, we have our own private CDN. That is a significant number of different providers to keep in mind. Not all CDNs deliver the same content because the same CDN properties do not exist on all our CDN providers. One of the reasons for this is also lack of automation. So you might be thinking, why not just manually configure all the properties that on all these providers? But I'll get to why this is a problem for us. So at Spotify, we are a large number of teams called squads. And we're working on different parts of the Spotify client and the infrastructure. Each squad may require any number of CDN services for their product. Anyone can create a Google Cloud bucket with the content they need. However, not everyone feel as comfortable configuring their CDN properties. Many of our developers have never configured a CDN before, and we think they shouldn't have to either in a perfect world. We also have to consider manually configuring this vast number of properties can be time-consuming and error-prone. So we do not want to be the squad who manually creates, updates, and deletes other squads' properties. Nor do we want them to be required to learn how to manually create, modify, and delete properties on 3 different platforms. To support Spotify's use cases, we inevitably had to create a system that any developer can use. and which automates the configuration, deployment, and activation. Essentially, we had to provide the CDN-as-a-service, if you will, to support our developers and the rapid growth of the company. The product would internally be called Squad CDN, and I regret to tell you that this product is not open sourced. But you may today, for instance, consider maybe Terraform. There's a demo of it outside in the developer zone. So creating a service with Squad CDN is as easy as creating a bucket with your content, fill in a human-readable settings file, committing it to Git, review, merge, and deploy with our continuous integration service of choice, Jenkins. Consider this example of a user input in the human-readable settings file I was talking about. We see quite few variables, further simplifying the setup. These are the only variables that will really vary between the different properties, but there are also variables here assumed true or false unless stated otherwise by a user, which also further simplifies. So more on what Squad CDN is and what it does. Languages used for tools and services at Spotify are Python and Java. Squad CDN is a simple set of Python files that ingests the settings file I'll be talking about. Once this file is ingested, Squad CDN generates VCLs using VCL templates and uploads the corresponding VCL to whatever properties needs updating or to be created. To add Akamai to this mix, we need to generate JSON configuration from the settings file as well as VCL. For version control, we use Git, which is also important in our workflow of code reviewing. Once new code is merged, it is automatically tested with the help of Jenkins. The last step for deploying changes is manually done through clicking a button in Jenkins after hopefully successful unit tests. This gives us the last bit of control we want before the new configuration goes live. Before we started this project of integration of the Akamai APIs, Squad CDN supported 1 out of 3 public CDN providers and our private CDN. This was all good, better than nothing, but we could do a lot better. After all, this prevented teams from deploying their services onto public CDN providers instead of one, and it could also cause manual work for us configuring them. So we started looking into the Akamai APIs with hopes of integrating them into Squad CDN. Before we move on to Akamai's API, we must be clear on why even bother with automation. Why don't we settle for configuring things manually and just lean back until the next request comes in? Here are some key points to when I think you should consider automation. If you touch your properties often, whether it be changing configuration or adding properties often, you should think of making some simple tool for this. Another point is if you have a multi-CDN environment. This often means double the amount of work or more. An important point not to forget is using automation to make CDN deployment more accessible to others in the organization. This can greatly offload your team, but also make deployment quicker for your coworkers. They would rely less on you and your work time when doing their configuration changes. There are some more benefits to automation. I've already talked a lot about how it eliminates manual work. But eliminating manual work means we eliminate much of the human factor. Humans are fallible. We don't do consistent tasks very well. A very important benefit is automated tests. Testing is a very powerful tool to sanity check the small piece of manual configuration needed to run the tool, or even test against your properties in a testing environment before deployment. Another benefit is that automation can give you a nice rollback process. If you use Git, you can revert your changes, merge, let your continuous integration deploy the old configuration, and you're back. Last but not least, let's not forget that you can also automate the creation of alerts and graphs with your tool. Imagine all new properties automatically have their corresponding alerts in whatever system you use. Missing alerts is something we don't want, but we also don't want messy manual alerts with a skewed naming standard, enough to cause you a few seconds of confusion when your page, or slightly off settings for the traps, causing alerts to fire off too early or too late. So now we have covered our in-house tool, Squad CDN, and we have covered why you probably should automate your CDN deployment. So let's deep dive into our own Akamai API integration. This will be some storytelling through our iteration as we progressed with the coding. So it all started when a colleague and I were invited to Akamai's bootcamp. It served as a good inspiration for us to play around further with the API. If you can't attend an Akamai bootcamp, I recommend checking out the bootcamp website. Go through the first steps and just set up authentication and try out a few API calls. By doing that, you have everything set up to get started. While you're here at Edge, you can head over to the hands-on labs and developer zone to set up authentication and learn more about the APIs. It's a good opportunity. So anyhow, after the bootcamp, my colleague and I together made a client with different API calls. We played around manipulating a test property, and our Akamai client eventually filled up with API calls we identified useful for an integration into Squad CDN. Our Akamai client has a controller class that contains functions for the API calls we need. This is an excerpt with a few examples functions in the controller. The Akamai client also contains error handling functions. This is because when an API call causes an error, it will break runtime in your Python code unless you handle that error. This became very evident when we made an activation function. All warnings produced during activation broke runtime unless we handled them. So after us playing around with the API and gaining more understanding of how things work with Akamai, it was time to start planning the actual integration. We had to figure out what workflow do we want? Are there any constraints? We need to fully understand the workflow of creating a property and what it entails, updating properties and activating them. Things we figured out while playing around with APIs includes the following. Configuration is fetched in JSON format and also posted in JSON format to the API endpoint called PAPI, or PAPI, but I like to call it PAPI. Host names are created with its own API call to PAPI. CP codes are generated with an API call to PAPI. Secure host names needs to be created with an API call to something else called SPS. You can then link this secure edge hostname to a hostname in Puppy with the secure flag set to true. Advanced metadata cannot be added nor edited via API. For any changing variables in advanced metadata, you can instead use custom user variables. Google Cloud Storage authentication needs advanced metadata. This was a pain point for us we couldn't ignore. We need Google Cloud Storage authentication since almost all of Spotify's buckets are in Google Cloud Storage. Initially, we thought we had a solution to this by making a template property where Akamai can configure this advanced metadata for us in this property. And then we could clone this template in order to make a new property. Remember that we can't add advanced metadata ourselves, but we can clone a property with advanced metadata. So let's start off with the first iteration of the design. We want to keep simple settings in this human-readable .yaml format because we want this tool to be simple for any developer at the company to use. We could, of course, take this way further and make a whole UI for users to put in their information, but we'll stick to a text file for simplicity. When the settings file is ingested, we need to create a full set of JSON config. To do this, we do not only need the settings file, but also a template configuration in JSON format. A Python script will read from both these sources and create the full JSON configuration. The next step is to check if the property already exists. If it doesn't, we need to create the property by cloning our template with our advanced metadata. If the property exists, we can go to the next step, which is to ensure that all of the host names exist. It might be that someone updated the list of host names, some might have been added or deleted. So these are now created with a separate API call. And right. Oh, yeah, sorry. Okay, right. Of course, we need to create a new property version before we touch the host names. Sorry about that. Right. So, back to where we were. So we list all the properties and we look at the property names. And if the property doesn't exist, we need to create the property by cloning our template containing our advanced metadata. And if the property already exists, we go straight to the next step, which is to create a new version of the property, because we always want to edit a new version. There we go. Now, next step is to ensure that all host names for the property exist. It might be, again, that someone updated the list of the host names. Some might be added or deleted. So these are now created with the separate API calls. If any secure host names are added to a property, these secure host names need to be created, then again with a call to SPS after being created in Puppy. The last two steps is to push the JSON configuration, and lastly to activate it to production. Or if you prefer, activate the new property version to a staging for additional testing. Turns out, cloning templates with advanced metadata was not scalable. If we ever needed to edit this advanced metadata or add new advanced metadata, this will only affect the template and not any of the already existing properties. And yet it is highly likely for us that new advanced metadata will be required in the future. We also completely forgot about CP codes. With a workflow, all properties will have the same CP code. This might not be a problem for everyone, but with potentially a lot of different properties, this can impact, for instance, the reporting and invoicing, and CP codes are also useful for purging. But however, this is easy to change. We could, after the cloning process, generate a new CP code for each property. So consider this workflow as a nice first iteration. It works if you want to keep your automation simple, which is a really good start. This workflow supports creating and modifying properties, and you can add CP code generation after you create a new property. The only thing it doesn't support, which might be on your list, is the deletion of properties that you don't want anymore. So we were left with some hopes and dreams we wanted to implement to make this really work for us. One of them was custom behaviors to replace advanced metadata. And this is all very new. So we beta tested this functionality with Akamai. More on custom behaviors in the next slide. We also wanted unique CP codes for each property. With this, we can check if a property exists by looking for an associated CP code. If there's none, we can create a property and then a unique CP code for it. But most of all, we wanted a visible diff. It does not have to be detailed, but given the workflow, we can check for what potentially has to be updated. Is it the CP code? Is it the rule tree? Does the property need to be created, etc.? And this will make it a lot easier to work with CDN and also enable us to delete properties that have vanished from the settings file. So custom behaviors was a big thumbs up for us. With custom behaviors, we can ask Akamai to create them for us, get the behavior's unique ID, and just put this ID in whatever properties rule tree we want this particular custom behavior on. And with custom user variables, we can adapt the variables to each property. And also we can freely link multiple custom behaviors to any one property and add more in the future. So with the second iteration, we went for another approach, very focused on making diffing a reality. While the settings file together with a template is used to create the target configuration, this design gets a list of all the CP codes available from Akamai, iterates through that and matches those codes to a list of all properties available. If a property is missing a CP code, this means the property is new. We will then insert a temporary placeholder CP code until such a code is generated later on a later stage, when the diff has been reviewed and merged. To create a diff, we have to fetch the current configuration from Akamai and compare it to the target configuration we want. If the property doesn't exist, the current configuration will be empty. Thanks to the diff, we don't need to create a new version of a property we actually know, unless we actually know that we want to update it. So otherwise we would have to create a new version and push every time upon each run. And it also enables us to delete properties that have been removed from the settings file. However, by being dependent on this, it's very important that our code works. We cannot have any bugs in it. Our code relies on being able to download the configuration from Akamai and interpret it correctly. Pushing a new configuration upon each run is a much simpler way of working, but it will not provide any visible diff to view. So here's a little code excerpt from the diff Python file. So it compares the target state configuration with the active state configuration. So consider the JSON configuration as a tree of lists of dicks and lists with dicks. So this creates a whole rule tree. So this function takes a path in this rule tree for comparison. The last steps are reviewing the diff and pushing the new configuration. If the property is new, a new property will be created along with host names, and the placeholder CP code will be changed for a newly generated unique CP code. If the property already exists, a new version will be created, the host names updated if there's a change to host names, and the new configuration pushed if it has changed. So we only push the changes we actually change. So when our property is properly configured, we need to activate it. And activation has been a little bit bothersome to us because it currently takes a long time to activate a brand new property or a property with a change that is considered a large change, which could be host names. And it can take up to an hour. And therefore, activation generally does not work with Jenkins continuous integration tool. But the activation with Jenkins works for small changes that support rapid activation. But for now, you can build your own script with APIs that just polls Akamai for the status of the property version you are activating. Developers Zone general session mentioned yesterday how you can use Jenkins for continuous integration with Akamai. So I recommend you to check out that video to learn more. For tests, we have unit tests with PyTest run by Jenkins to sanity check our code. But there are a lot of other things here you could do. For instance, you can activate your property to a staging environment and run tests toward it for further assurance of its functionality. So let's wrap this up. I would say these are rather conclusions than a summary. But with all of the multiple benefits you get from automating your CDN deployment, take your time to automate your manual tasks. Don't be too busy to automate. Start off with your basic automation needs. Don't believe you need to automate every little detail on your first go, or else there won't be any automation. Keep it simple. And as you use your tool and you notice your requirements are changing or you need more functionality, add it later. And don't forget the tests. They are a very powerful tool that can catch things that are hard to catch manually. So I will try to answer any questions if you have any. I see a few hands. Shut there. Mm-hmm.
But because we use the same zip code, the problem is that if I use dev.create.com, and then someone by mistake adds dev.create.com to the new code
It's probably something that hasn't happened to us yet, but this is a perfect time you can use your test to sanity check that if a hostname is already in use, your test should break so that you can't push it, because it will break things in the wild. Right, and there was someone else first. The DNS we do manually because we have our own DNS service at Spotify as well, so we have to do that manually. Yeah, exactly. So that's something someone can do, because anyone can edit DNS as well as Spotify. So a developer could add this new DNS hostname before filling out the settings file as well in Squad CDN. Yeah, I wish I could. I went to the demo yesterday. So this is just something I've heard a little bit of, and as far as I understand, it's an open source software. It's community driven. So I believe right now there are some early stages of some Akamai integration there, and I believe there's already integrations with some other CDN providers in it. I don't know. Right. Go ahead and check the demo. Sorry, can you? Oh yes. So there's definitely a nice CLI for the APIs. Something you can try out hands-on at the hands-on labs, and I really recommend you to check it out. Yeah, you can use the CLI. Oh, sorry. I didn't catch all that. Yeah. Well, yes. But I believe everyone who has their own bucket has their own origin hostname. Pretty much.
So, do you manage the balance of which CDN? I imagine you can do that via CDN command. What do you do? And factors that I think about all the time are latency, cost, availability, temporary availability issues.
Seems like I have. It seems like I could do a lot of storytelling here, so maybe we should take that after the presentation. But I will gladly discuss this with you. Yes.
I assume you just enabled basic functionality. How much effort do you have in manually optimizing?
Sorry, I couldn't get that.
I'm assuming that you only have basic functionality in your settings file, right? Just basic features.
Right.
How much effort do you have in optimizing configuration? Is anything still manual?
Yeah. So right now, obviously, all properties are going to be very, like, plain. So that depends on what you put in the template, really. So you can still do all of those settings in the template. But then again, we have I mean, we know our content, so we probably have a quite easy environment to work with in that sense as well.
Are your tests, are they unit tests just to ensure that the format looks the way that the template should, or are they integration tests? Do you spin up the data components or the simplicity, or what do you actually do in your integration?
That is, maybe you could fill them in, because you have worked a lot with Jenkins and the actual integration tests of Squad CDN. Oh, I would love to have those numbers. No, but we don't have those numbers. But from an everyday working day perspective, that means so little of our work time is spent configuring these things. It's lovely to see how a squad can just send us a little pull request and that's it. We just have to review it and merge it, and that's it. So it definitely happens. A lot of property edits and creations. Yeah, but this can also mean that they can put out their own fires quicker, because it's not like they need to file a ticket with our team, like could you create this property when you have time, or could you change this property when you have time, so we don't have a ticket queue or anything. They just have their own workflow, right? And it's just so much faster. Yep. It's a mix. Some content is available in unencrypted buckets and unencrypted content, and some of it is encrypted. So it's both.
Thanks for sharing all the dependencies. Was there any hesitation, or do you have consideration now after using it, which dependencies you feel happy about and control plane? Like if something goes wrong, like for example, I don't treat Git as like tier 1, reliant, and a fire. What's your perspective on that?
So are you saying if something in this workflow should fail, or?
Yeah, like you need to roll back, spot something in production is going wrong.
Right. Yes.
Feel comfortable with Git or any
I do, but at the same time, there's always fallbacks. You can always log into Luna and do a manual rollback there in the end. So that feels very secure. But I'm also very confident that whenever I deploy something, it will only deploy upon success. That's always nice. I think actually we have to wrap up. I'm very sorry, but I will be available here. Yeah, we have like 30 seconds. Mm-hmm. I suppose that's just up to how the API updates the origins, and that's it. That's yeah. That's it. Yes. I'll be happy to talk to any one of you after. I'll be around here in the developer zone. So come say hi.